Hello and welcome to this presentation about the main styles of data schema. The content of this presentation is free to use, published as a Creative Commons, which means it's open source. You are welcome to reuse the concept, text, and illustration as you wish, provided that you cite the source, which is the Engage Meta community. I invite you to visit our website for more information on our publications. My name is Pierre Bonnet, and I bring over 30 years of expertise in the field of information system architecture and data management. Please visit the website of Engage Meta community for my presentation. Starting from the data modeling, here are the three styles of data representation that I will consider. Table relation for the relational approach, document and key value for the big data approach, and finally, node and relation for the knowledge graph approach. The initial modeling can vary according to these three styles. However, the semantic level data model should not be dependent on the styles, only the logical level is. Here are the data schema styles that I distinguish according to the three modeling styles. For the table and relation approach, strict schema, meta-schema, and dynamic schema. For the document key value approach, it is schema-less, also called document schema. Finally, for the node relation approach, I distinguish between schema-less and schema by convention. The strict schema is the native mode of operation for relational databases like Oracle or MySQL. The data structure is fixed at the data schema level. Structured data are primarily managed and more rarely unstructured data. This technology ensures OLTP transaction management for online transaction processing and ACID for atomicity, consistency, isolation, and durability. The data schema also allows for an optimized management of relation with foreign keys. The downside of this style is its rigidity. Indeed, when the data structure changes, it is necessary to modify the data schema and redeploy the system. With the meta-schema styles, a common data schema is used to abstract any specific data schemas. The solution is more flexible than the strict schema since it is no longer necessary to redeploy the system when the data model changes. It is enough to publish it in the meta-schema, which is fixed. This mode of operation can be found in no-code databases like Airtable or Knack, and also in certain master data management solutions on metadata management when they are driven by models. As with the strict schema, the transaction management is of good quality, OLTP and ACID, as well as the management of relations with foreign keys. The underlying database technology is often a relational engine, as for the strict schema style. However, the meta level of abstraction comes with a possible degradation in performance on large volumes of data and remain poorly suited for the processing of unstructured data. The third style is the dynamic schema. This is a new approach at the time I'm recording this video. The goal is to benefit from the best of both strict schema and meta-schema styles with the added ability to manage unstructured data. The principle is that the strict data schema is automatically generated at the time of the first data loads. Then, as the data structure evolves, the system is supposed to have the intelligence to adapt the data schema on the fly and proceed with the migration of data from the old schema to the new. The database solutions HarperDB position itself with this dynamic schema style. I have not had the opportunity to put this technology into practice, so I don't know if it is refined today. However, its positioning is very interesting and deserves to be carefully studied. Let's now look at the schema-less or document schema. We are now in the mode of NoSQL or big data. For example, we find here the MongoDB databases, and we could also mention HarperDB again, which seems to also be able to act as a big data. With this style of schema, there is no longer any description of the data structure, so the metadata is poor or even non-existent. The principle is to store documents or block of data without rich internal structures. The relationship between data are no longer managed by foreign keys, and the notion of relational management is lost. To find these links, it is necessary to denormalize the data, that is, to copy certain blocks of data into hierarchical structures, which leads to data duplication. This denormalization is reasonable because it is a matter of accessing data for reading, but it creates significant functional and technical constraints when it comes to making modifications on data that are related to each other. The management of OLTP and ACID transactions is partial. This style of database is capable of handling structured data, but with few or no link, and especially unstructured data with massive storage volumes. Finally, let's look at the schema-less style of the node relation approach, also called Graph-schema. Here we find knowledge graph-oriented databases like Neo4j and StarkDog. In this style, a unique data schema is proposed by the database, which then limits itself to a table of nodes with relationship between nodes. It is a very minimalist schema that can absorb any data descriptions. A table is an instance of a node, and a foreign key is a link between two node instances. OLTP ACID transaction management is possible, but often partial, especially due to the difficulty in expressing referential integrity constraint rules. Indeed, since each foreign key is abstracted in a simple way as a link between nodes, it is not natively possible to provide cardinalities or other functional integrity constraints. With this solution, structured data are mainly managed. The interest of this minimalist schema is the system's ability to immediately absorb all sorts of knowledge. Indeed, each piece of knowledge can be abstract in the form of items that correspond to nodes and relationship between these nodes that express certain semantics. This is why the flexibility of graph schema is interesting for managing ontologies where the complexity and evolution are significant. With a strict schema, the ontology will be fixed. With a meta-schema, it will require a modeling step with each evolution of the ontology. And with a document schema, there will not be sufficient links. Only the graph schema offers both the flexibility and richness of links between the data. When it is necessary to formalize a stricter data schema, knowledge graph-oriented databases allow the use of a schema by convention styles. It is then enough to create a data schema modeler above the graph schema and to plan at the application logic level the referential integrity constraint. In this case, we approach the meta-schema style of the purely relational approach, albeit with less power in OLTP ACID transaction management. There is no choice grid for the best style according to predefined context. Each case is different. Nevertheless, the following criteria should certainly be considered. OLTP ACID needs, structured and/or unstructured data, read-only access or also update access, complexity of the links between data, stability of the data schema. For projects in the startup phase, a meta-schema approach is recommended to ensure the agility of the development process. For ontology management, the graph schema style is the best to be able to quickly absorb knowledge. Finally, for mass storage of unstructured information with few links between them and in read-only mode, NoSQL with the document schema styles is interesting. Of course, in the context of building a global data architecture, it is certain that several database technologies must coexist. It is then important to keep control with appropriate overall governance. This also involves a good understanding of the data schema management styles that I have just described in this presentation. I have not been exhaustive on the criteria or the styles of schema. The important thing for me was to make you aware in a few minutes of this field. As you have understood, it is important to consider for the construction of your data architecture. I've completed this presentation. If you have any question about our vision, do not hesitate to contact me and follow me on LinkedIn. Thank you and see you soon.